Hello. So this is a continuation of the work on reviewing triangles. And so what I would advise you to do is make sure that you do these problems. Then make sure that you go in and you do the classwork for today that is related to these problems and take as much time as you need to make sure that you get it right and that you write the work down. I will be online every day from 11 to 12 to answer any questions you have, or you can post questions online, or you can email me with questions. And then have your notes when you sit down to take or possibly retake the midterm test from last week. You will find that the notes that you take while you're doing your classwork are exceptionally helpful when you go back and take your test. Okay, so today is all about triangles. So we're going to look at a couple of questions that have to do with the trig functions. You did some work on trig functions last time, but it was finding missing sides. Today we're going to look at how to use the same trig functions to find missing angles. And then the remainder of the practice problems have to do with the law of sines and the law of cosines. So let's start with number one. We're looking for this angle right here. So I'm going to call that x, just so I have something to put in my equation. And I see that I'm dealing with a right triangle. I know that because of this little box right here. So I've got some sides. I want an angle. So that tells me trig functions. So SOHCAHTOA helps us remember sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we have to identify what sides we have, what angles, and then figure out which one of the three trig functions we're going to use. So if this is the angle that I'm looking for, the long side opposite of the right triangle or right angle is always the hypotenuse. Our angle, our reference angle, is always made up by the hypotenuse and the adjacent side, so that's the adjacent side, and that leaves this one to be the opposite side. So I have the opposite and the adjacent, so that is tangent. So even though I'm looking for the angle measurement this time, I still have opposite and adjacent, so I want to use tangent. So instead of putting an angle measurement like we did last time, I'm just going to put the x in there because I don't know what that angle is yet. But I do know what the opposite and adjacent are. So the opposite is 14 and the adjacent is 29. So if I put that in my calculator, I get tangent x equals about 4.82759. I rounded a little bit when I cut that off in the calculator, but that's okay. Now, to find out the angle measurement, I need to do the inverse operation on both sides. So that would give me the inverse tangent of tangent x equals the inverse tangent, because when you're solving an equation, whatever you do on one side, you do on the other, of 0.482759. My inverse tangent and my tangent cancel out, so all I'm left with over here is x. And if I put inverse tangent of 0.482759 in the calculator, I find that that angle measurement we're missing is approximately 25.8 degrees. Okay, so if we look at this one down here, this one actually looks identical to that one up there. Our missing angle is right here. Long side would be the hypotenuse. The other side that makes up the angle would be the adjacent side, and then we have the opposite side. So it looks like we're going to have exactly the same setup. So tangent x equals 27 over 38. Tangent x equals 0.710526. I do the inverse tangent on both sides. Now this would work the same if you had sine or cosine. You would just do the inverse sine or the inverse cosine. My tangent and my inverse tangent eliminate each other. And if I put inverse tangent of 0.710526 in my calculator, I get approximately 35.4 degrees. So a test taking tip, your test is multiple choice. So if you are not able to get past this right here, if you're not sure how to put that in your calculator, if you had choices A, B, C, and D, and they were all angle measurements, if I did the tangent of 35.4, I'm going to get about 0.7105. So if you can't quite put this in your calculator, go backwards and do the tangent of each of the multiple choice answers and see which one comes out closest to your decimal. All right, so we're going to move on to law of sines, law of cosines. And law of sines, law of cosines work on triangles that are not right triangles. In questions 1 and 2, those are both right triangles. We notice this one here is not. I have an angle measurement of 108 and one of 31. There's absolutely no way mathematically that this angle could be a right angle. So we know this can't be a right triangle. What I'm looking for is side AC. So I'm going to call that X for right now. That's my missing side. I could also call it B because it's across from angle B. The law of sine says that the sine of an angle, the sine of each angle divided by the side opposite of that angle is going to be equal to the other angles divided by their sides as well. So what that would look like in our problem is that the sine of 108 divided by X is equal to, I have 31, so I can do sine 31 divided by 5. Here's my 31. The opposite side is always the side that doesn't make up the the angle. So these two sides make up the angle, so that means that that one is its opposite. And so that would be side A. And so that goes with the angle that's 31 degrees. So now I just cross multiply and I get 5 sine 108 equals X sine 31. If I put that in my calculator, 5 sine 108 is about 4.75528. And the sine of 31 is about 0.515038. Now notice I've left a lot of decimal places because if I were to cut this off and make this 4.8, that would really reduce the accuracy of my answer. So if you're going to put your stuff in the calculator early, leave a lot of decimal places. Okay, so now I have 4.75528 equals X times 0.515038. And so I'm going to just divide by 0.515038. And those cancel out. And what I get is that X is approximately 9.23. All right. So let's go up here and look at question number 4. Question number 4 says find BC. So we're looking for, I'm going to color this in a little bit so you can kind of see it. We're looking for this side over here. And I notice I only have one angle measurement and 2 side measurements. I want a third side. I'm only concerned with one angle. So that's not the law of sines because the law of sines involves 2 sides and 2 angles. So this is actually going to be the law of cosines. So the law of cosines is c squared equals a squared plus b squared minus 2ab cosine C. Now, notice I didn't give this a variable or anything before I wrote the formula. I want my missing values to be centered around C, and that's even if I have to relabel my triangle. So that's what I'm going to have to do. So my missing side, I want my missing side to be C. So that means this angle across from it, this 60-degree angle, that's got to be angle C. Now my other two sides and angles, doesn't matter which one I make, A or B, as long as wherever angle A is, side A is across from it, and wherever angle B is, side B is across from it. So now that I have my triangle relabeled, I feel like relabeling a triangle is a lot easier than memorizing 3 different cosine formulas, or law of cosine formulas. So if you're willing to rearrange your triangle, you only really have to know this one. So now we can start plugging things in. So C is the value we want to know. So C squared equals A squared plus B squared. So 9 squared plus 7 squared minus 2 times A times B cosine of big C, so that's the angle measurement, 60 degrees. So C squared, I'm going to just simplify this math here a little bit. 49 plus 81 minus, and then if you put all this in your calculator, believe it or not, it comes out to just 63. So then, if we do all this calculating, C squared equals exactly 67. And then we undo a square by taking the square root of both sides. So C is approximately equal to 8.19. All right, so now I want to find the measure of angle C. So that's this angle right here. So again, I have all 3 sides and I'm interested in one angle, so that tells me law of cosines. So C squared equals A squared plus B squared minus 2AB cosine C. Except this time I don't know what big C is. So I'm going to label my sides. So if this is angle C, I'm going to go across from that. This will be side C. Here's angle A, so 10 will be A, and there's angle B, so 11 will be B. All right, so now I'm just going to plug into my formula. So this gives me 5 squared equals 10 squared plus 11 squared minus 2 times 10 times 11 cosine big C. All right, so if we just start doing some of this calculating, 5 squared is 25, 10 squared is 100, 121, and then 220 cosine C. All right, since the 100 and the 121 are both positive, I'm just going to subtract them from both sides. And what I get over here is negative 196 equals negative 220 cosine C. I'm going to divide both sides by negative 220. And I get about 0.890909 is cosine C. So we do our inverse cosine of 0.890909 and the inverse cosine of C. And what that gives me is that angle C is approximately 27.01 degrees. And that little circle right there is the degree symbol. Okay, not too terrible, right? Using the same formula, just solving, except this time we had to solve for the angle measurement. So that means inverse. Again, this would be multiple choice. So if you got yourself down to this step, you just start plugging in do, cosine 27, see if you get close to 0.899, do the cosine of each choice, and then see if you get close to that 0.8909. All right, so this is our last one, and this one is tough. Okay, so what I want to find is CB. So CB is this side over here. Well, I see that I have two angle measurements, and I have no sides, and this is definitely not a right triangle. So with two angle measurements, I could use the law of sines. I'm going to call this over here X. I could use the law of sines if I knew what this was. So let's call this height Y. Okay, so I'm gonna set up my law of sines and just see what I'm missing. So if I knew, all right, so the sine of 43 over Y, if I knew it, would be equal to the sine of 75 degrees over X. Okay, so we've got some things to figure out. So I'm going to ignore this triangle for a minute, and I'm going to focus on this one because there's a lot of measurements in this triangle. And I notice also that it's a right triangle, so I can use my trig functions. I see that I have the hypotenuse of this triangle. I have a 58-degree angle. I have the hypotenuse. This would be the adjacent side, which means Y would be the opposite side. So I could actually figure that out, I think. Okay, so I want to know the opposite. I have the hypotenuse, that's sine. So off to the side here, sine 58 degrees equals Y over 5. Okay, so I'm going to go ahead and multiply both sides by 5. And when I do 5 sine 58 in my calculator, I get 4.24024 equals Y. Okay, so I can rewrite this equation. Sine 43 degrees over 4.24024 equals sine 75 degrees over X. Well, now I can just cross multiply. Put my calculator on the paper so it stops sliding around. All right, so cross multiply. I get X sine 43 degrees equals 4.24024 sine 75 degrees. Okay, so now I gotta put that in my calculator. Okay, 4.24024 times the sine of 75 degrees. Oh, I put too many dots in there. Okay, gives me that X sine 43 degrees equals 4.09576. And then I want to go ahead and I'll calculate the sine of 43. And that gives me, oh, yeah, close your parentheses there, 0.681998. then I'm going to divide both sides by 0.681998. And I get about 6.01. So x is approximately 6.01. And I see that the 5 was in centimeters, so that would be in centimeters as well. Okay, so remember, go do your practice problems, write down the work for your practice problems, do the practice problems, there's only 5 of them, do them as many times as you need until you get them correct, ask questions if you need to, write everything down, because those notes are going to be very helpful to you when you go take your midterm test or you retake your midterm test. Okay, I'm online every day from 11 to 12. You do have to share that time with my other classes. So if you come on, it's hard to tell how many people are going to be there. So just be prepared to be a little patient if you need to be, and make sure that you come prepared with whatever questions you have. In fact, it's great if you can, message me, email me or something ahead of time with your questions. But I hope to see you between 11 and 12. I will post the code to get onto Google Meet in the morning. Okay, bye.